Yeah, hello everyone. Good afternoon, and welcome to day 4 of the GeoPython 2021 week. It has been exciting, and today we would be looking at how we can use Python in reservoir characterization. And taking us on this journey today would be Dr. Fatai Anifowoshe and Destiny Otto. Fatai Anifowoshe is a research scientist at the Advanced Research Center in Saudi Aramco. He obtained his PhD from the University of Malaysia in Sarawak, his master's degree from King Fahd University of Petroleum and Minerals, KFUPM, in Saudi Arabia, and a Bachelor of Technology degree from the Federal University of Technology, Akure, in Nigeria, all in computer science in 2014, 2009, and 1999 respectively. He worked as a software programmer at HTRDG Computers in Akure from 2000 to 2001 and Obafemi Awolowo University, Ile-Ife, Computer Center from 2001 to early 2007. After his master's degree, he worked as a research engineer at the Research Institute's Center for Petroleum and Minerals at KFUPM. His research interests include the application of machine learning, hybrid intelligence systems, ensemble machine learning, and deep learning in the geosciences and petroleum reservoir characterization. He has published over 50 papers in conference proceedings and journals and disclosed 3 patents and filed 2 patents. He is a professional member of the Society of Petroleum Engineers, SPE, European Association of Geoscientists and Engineers, and International Association of Computer Science and Information Technology, and also Nigerian Computer Society. You're welcome to the GeoPython Week, Dr. Anifowoshe. I would leave you to do your thing now, sir. You're welcome, sir.
Thank you
Thank you
very
very
much
much.
for the nice introduction. Do you hear me, please? Very clear? Okay, good. And you are able to see my screen, everyone? Great. So thank you very much for the introduction. And I thank Fluxgate Technologies and Mr. Adetola, and of course, the rest of the organizing team for the invitation to deliver this keynote address today at this very nice and interesting event, GeoPython Week. To everyone out there, good morning, good afternoon, and good evening, wherever you are. And to the Muslims, I say Eid Sa'id and Eid al-Mubarak to everyone. Happy holidays to everyone. It's a great pleasure to be here today, and it's always been my passion to support this kind of initiatives, especially when it has something to do with the youth and the young professionals who are, of course, going to be the future leaders in the academics as well as the industry. So as mentioned by the moderator, I will be talking about machine learning in petroleum reservoir characterization, the pitfalls, the opportunities, the challenges, and of course, a few recommendations on how to address the challenges. So my agenda is very short. Basically, I'm going to cover all the keywords in the title. Of course, I will start with some very brief introduction. So I will go into the some of the emerging opportunities, and of course the challenges we are still facing, and of course a few recommendations on how we can move forward. We cannot be talking about artificial intelligence today without acknowledging that we are in the fourth industrial revolution. And very quickly, we have passed through the first one around 1784, which was all about mechanization. The second revolution was in about 1870, which was about mass production and electricity. And the third one was in about 1969 to 70, and it was about the computer revolution, about electronics, and about full-scale automation. But in the fourth industrial revolution, it was a massive invasion, I would call it, of technologies, and which has actually come to invade our life, hopefully positively. And it did not come just with one or two technologies like we had in the previous revolutions. It came with a massive set of technologies ranging from big data analytics to robotics, advanced simulations, massive system integration, industrial Internet of Things, cybersecurity, additive manufacturing, cloud, and so on. So with this, now I'm going to focus on the artificial intelligence aspect of the fourth industrial revolution. And I see AI today as a serious business. And why do I say that? For the first time in my life, I'm seeing a minister dedicated to artificial intelligence, and it happened in the UAE. And they were serious about AI application in the UAE to the extent that the minister said in an interview with the CNBC that the UAE is looking at AI at a global scale, at a practical scale. Okay, the government is coming up with a practical guide on how AI will impact the global economy, starting from the UAE. Okay, and in the same UAE, I'm getting to know, as far as I know, it is the first time I'm hearing about a whole university set up and established to focus on only artificial intelligence. So that gives me the impression that it is now a serious business. And not only that, even on a global scale, okay, AI leadership is actually determining the leadership in the world now. Mr. Putin, for example, says that the nation that lives in AI will be the ruler of the world. And this guy is serious about it. Even in China, the president says that China is going to use AI as a race for the future of technology. And of course, the former US President, Donald Trump, was trying to accelerate America's leadership in the area of AI. So, I mean, it's all about competition now. And as I said earlier, whoever leads AI, whichever country leads AI now is going to be the leader of the world automatically. Now, let's have some introduction about what exactly is AI, artificial intelligence. There are so many definitions out there, but one of my favorites is this very short and succinct one that says it is a science and engineering of building intelligent systems. And from the definition, you will see that AI is about science, it's about engineering, and it's about systems, intelligent systems. And these systems can come in form of hardware, they can come in form of software, or even both. An example of a hardware part of intelligent systems could be a robotic arm that is programmed to do a set of operations. For example, grab a bottle of Coke, pour in the liquid, and put in the cork. It can come in form of software. So nowadays we have a lot of intelligent softwares on our phones, in the industry. They are all trying to extract knowledge, trying to recognize patterns in our data. And also we can have a combination of both hardware and software, and we have this all over as well. We have some intelligent rovers that are programmed and developed to perform both the hardware and the software part of intelligent activities. Also, before I go into the success stories, a little peep at the history of AI. We cannot be talking about AI today without acknowledging the emergence of the computer field itself. So as we read in literature or in our Computer 101, the first computer came into existence in 1941. And after that, there have been one improvement, one development or the other. And very importantly, in about 1956, the word or the two words artificial intelligence, which we now abbreviate as AI today, was coined at a conference in Dartmouth in the US. So after that, there were leaps of developments until we get to where we are today. Today, what do we have? We have massive investment in artificial intelligence. We have AI algorithms now running on our smartphones. Facebook is using AI for automatically identifying people in a picture. Google is using AI. We have AI in our desktop computers, in our laptops, in the industry, all trying to crack data, trying to recognize patterns in the massive data that we generate almost on daily basis. This slide is very important to me. And if this is the only thing I will talk about today, I will really be very happy. I have noticed a whole lot of confusion among these three entities: artificial intelligence, machine learning, and neural networks. People seem to confuse them so much. I have encountered this in a number of conferences. In fact, in a particular conference, someone came to me to first trying to, complementing my presentation. And after that, he asked me, which method did you use? Is it AI or neural networks? So since that time, I have been including this slide in all my presentations in order to clarify the differences as well as the relationships among these three terminologies. And I call this picture the AI family tree. That's what I call it. So everything starts from AI, which is artificial intelligence, okay? And which we can, I defined it in the previous slide as the science and engineering of building intelligent systems. We can also see it as a branch of computer science that's also build intelligent systems. So everything starts from artificial intelligence. And when we say AI, okay, we are talking about a whole lot of other sub technologies, which includes natural language processing. These are, rule-based systems that are used for diagnosis, for arriving from causatives to results. Okay, an example of these are the language translators, automatic vehicle registrations, number capturing, and so on. Also, when we mention AI, we could be referring to expert systems. Okay, these are again rule-based systems that are, I call it, nested if statements that will lead us to causal agents to possible paths that we can follow. Also, when we say AI, we might also be referring to robotics, okay? So robotics is also part of AI. And of course, when we say AI, we can be focusing on the computational aspect of artificial intelligence, where we deal with algorithms and data. And this is where I'm going to focus on now to lead us to machine learning. Now, when we take the computational aspect of AI and we do what is called knowledge discovery, we do pattern recognition, and I'm going to explain each of these terms in the following slides. And we do also data mining, then we are doing machine learning in this way. Now, in the next slides, I'm going to take us through the process, the workflow for performing machine learning. And to do machine learning, we have to do these three things. We have to do knowledge discovery, we have to do pattern recognition, and we have to do data mining. So what are these things? Now, knowledge discovery. Some people think that, machine learning is, just go to Coursera, take 1 or 2 courses, then master a few algorithms, get hold of some data, and then you are live in machine learning, it has its own standard workflow that you have to follow. And if you miss any of the steps, you may not be successful in your machine learning application in whatever field. So these steps are very important. The knowledge discovery process is very important. It starts from knowing which data you want. So it starts from, first of all, declaring your objective. What exactly do you want to do? Okay? What exactly do you want to achieve? What challenge do you want to solve? What challenge do you want to address? And what data is relevant to this challenge that you want to address? So it's from going to the data repository, which might be multidimensional, multivariate, okay, containing different types of data, structured, unstructured, documents, flat, okay, whatever. And then establishing or focusing on the particular data that is relevant to the challenge that you want to solve. So this is called data selection, because not all data are useful for your challenge. Some data are meant for your challenge and may not be applicable for other challenges. So you have to be very specific. So you go to the data repository and then select those ones that you believe are relevant to address the challenge that you want to address. Now, after selecting this data, the data may not be in the right format for your machine learning algorithms to act on them. So you may have to do some pre-processing, okay? And this might include, doing some cleaning, removing blanks, filling some missing values, and so on. So this is called pre-processing. And this is a very important step because data don't naturally come in a good shape, okay? Unless you are working with, unless you are given some, already clean data, and this doesn't happen all the time. So you have to be aware of this knowledge discovery process. You have to know that in case you don't have this clean data already prepared for you, then you have to do it by yourself. So this pre-processing step after selecting your data is very important. After pre-processing your data, you might need to do some transformations, okay? So here, you might need to apply some functions on your data to put them in the right format. Sometimes when you have different types of data with different units, with different ranges, you might need to apply some min-max algorithms to flatten them, to level them up so that they are all in the same range, whether between 0 and 1 or between -1 and 1. So some research has proven that doing this actually improves the machine learning model performances. So after transforming your data, and now they are in a very good shape, then you need to do mining. So this step depends on exactly what was your objective in the first instance. So the data mining determines what method you want to use, because what you want to achieve will determine what method you want to use. If you just want to, detect some anomalies in your data, there are algorithms that you apply on that. If you want to make some predictions based on some correlations, then you have to use some predictive methods. And if you just want to classify your data, you want to detect some natural groupings in your data, then you apply some classification algorithm. So your objective determines which data mining method you have to apply. And after doing that, you have to evaluate the result, which is supposed to be a new knowledge that you are presenting to the people. So you have to evaluate that knowledge that, okay, have I achieved my objective? Does this result solve the challenge that I was trying to address? If yes, then we have a new knowledge. And if no, then we have to go back like in a loop to any part of the knowledge discovery process that we need to revisit. And also the data mining process includes different things, okay? You may want to visualize your data or results. You have to apply certain statistics to evaluate your results. You may have to, perform even machine learning algorithms, as I've said. You may have to store the result that you achieve in some database for further use by other set of people in a big workflow and so on. So all these things are very important. This list is meant to inform you that I'm not going to focus on these aspects in this my presentation. They are all very necessary. I assume that since the day one, most of this have been addressed, or if not, then the subsequent presenters, Mr. Olawale Ibrahim, Mr. Otto, Destiny, they will be touching on this. So I will not touch this, but just very quickly, I want my audience to know that, so far now, I have taken you through a journey from the fourth industrial revolution. I zoomed into AI. From AI, I was able to zoom into machine learning. So under machine learning, it can be, you can be working on supervised mode or unsupervised mode. So I leave the details to the subsequent presenters to handle. Then also, there is a goal that you have to achieve in the machine learning process. I may mention this briefly in few slides to come. And also, there are advances beyond the traditional machine learning algorithms. We have hybrid learning, we have ensemble learning, and also, lastly, now we have the deep learning. And as I said, all this will be handled by subsequent presenters. But one thing I just want to point out to my audience here is that as you are going into the journey of machine learning, whether you are using Python or using R or using MATLAB or using whatever programming language or whatever platform, one thing to keep in mind is that there are some instances that you actually need the shallow learning. And just very briefly, the traditional algorithms that we have today, like neural networks, support vector machines, fuzzy logic, decision tree, random forest, all these are classified as shallow learning. And then deep learning is the latest advancement that requires, that leverages massive amount of data that we have today. So one thing to note between these two is that the shallow learning has limitation, okay? As you continue to add more data, we actually know that to do machine learning, as I'll be mentioning in a few slides as well, you require a vast amount of data. So as you add more data, your shallow learning models will be increasing in their performance, but it has a point, a peak point, where when you add more data, it makes no difference anymore. And that's where deep learning comes into the picture to take the performance further. So for deep learning, as you add more data, you are guaranteed to have better performance. So that's why the focus more nowadays is on deep learning, because it gives you more assurance of better performance. However, there are still some applications where what all you need is shallow learning models and not deep learning. So, and I'm sure the subsequent presenters will make this clearer to the audience. So in summary, again, this is a very key takeaway for my audience to know. The AI is the superset. And under AI, we have machine learning. Under AI, we have the hybrid learning, we have the ensemble learning. And inside machine learning, we have the latest development, which is deep learning. So this picture is very important to be kept in mind by everyone as you go into the journey of machine learning. Now, this is the crux of this my talk. When exactly do we use machine learning? So people have this wrong notion. I call it wrong. Yes, it is wrong. That machine learning must be applied everywhere. I say no, I don't agree with this. Machine learning should only be applied where it is useful to be applied or where it is beneficial to be applied. Machine learning is not applicable in all cases. And one of the instances where we need to apply machine learning is when there are no existing rules or when there is no equation relating some causes to their results, or relating some inputs to some outputs that we are trying to explore. There is no established rule, there is no existing equation. So machine learning is a very good fit in that situation. And I usually give an example here that let's say someone today says that, okay, I want to build a model, a machine learning model to predict speed, okay, given distance and time as input. I say this is nonsense. We don't need machine learning for this because we know this universal equation that speed is equal to distance over time. This is applicable everywhere in the world. This is, it is true everywhere. So there is an established equation for that. So you don't need machine learning. So using machine learning would be a waste of time in that situation. And also, not only that, when there is no rule, even when there are rules and there are equations, but the equations are too complex to grasp. They are too complex to understand. And I have an example here. This is the popular Archie equation for those who are petroleum engineers among you. It says that to estimate water saturation, the SW is water saturation. It is equal to A which is tortuosity, okay? The ease or the degree of ease or difficulty with which a fluid passes through the rock matrix from one end to the other, multiplied by the water resistivity, okay? Then over formation resistivity multiplied by porosity, and then M is called the cementation factor. And then we also, and everything raised to power 1 over N. The N is the saturation index. If you have read about this equation, you will understand how complex the equation is, and you will also see how many assumptions were put into this equation to make it as simple as possible. So when you have a situation like this, we try to recommend, okay? We don't enforce. We try to suggest that, okay, instead of using this complex equation with all this bunch of assumptions, why don't you just build a model, okay, that will relate the inputs to the outputs more easily by learning from the data directly, by learning from the data itself. And of course, this equation, as simple as it might look, actually, if you want to apply machine learning, you might apply machine learning to determine the A itself. Another machine learning model will be used to estimate N itself, another one for M itself, and then a bigger model can then be used to bring all these things together to estimate water saturation. Also, even when the rules are simple enough, but when they are constantly changing, such that the rules are no more applicable in all the situations. I mean, you don't have a global rule. You have tiny rules, you have specific rules, but they keep changing due to different environments. For example, you have a rule that works only in a carbonate environment. You have another rule that works only in a dolomitic environment. You have another one that works in a shaly environment. So if you want to build a model that will be able to work in all these environments combined, then you need machine learning, because there will be no single equation that will cut across all these changing situations. Also, when the nature of the data keeps changing, again, this is when you need machine learning. And of course, when you have a large amount of data, okay, when you have a large amount of data, then it is an opportunity to build data-driven models that will leverage the signatures that are hidden in this data, the knowledge that are hidden in this data, that will bring them out and give us a new knowledge. So having said that, what are the emerging opportunities to apply machine learning in the industry? Of course, the fourth industrial revolution is a great enabler. Nowadays, we have massive amount of data. We have sensors everywhere, and they are capturing data every single second. So we have massive amount of data nowadays. So they are giving us opportunities to apply machine learning. And also nowadays we are focusing on better utilizing the real-time data that we have in order to make some decisions in real time. So the LWD that you have, the logging while drilling, the measurement while drilling, and so on. So we want to utilize them. The static equations that we have may not be able to handle the real-timeness of this need. Also, the basic statistics that we are using may not be applicable also in this objective. So, and also another opportunity that we are having to apply machine learning in the industry is the downturn in the oil price. Okay, you will have read in the news that Saudi Aramco remains the most lucrative or the most successful oil company in the world today. You might be wondering, why is that? Aramco is leveraging digital tools, is leveraging digital transformation, is using advanced technologies to reduce costs, to improve productivity, to increase efficiency, thereby increasing its profits. And not only Aramco, some other companies, for example, Apache is using machine learning to replace manual production forecasting for unconventional wells in the Bakken Formation and the Permian basins. Also, they are using enhanced drilling efficiency through early anomalies detection to avoid non-productive times. And also, companies are leveraging abundant seismic data to do automated interpretation. So all these are giving the opportunity to reduce cost and improve efficiency. And also, we cannot forget about the COVID-19 pandemic. It's also giving us the opportunity to apply cutting-edge technologies to reduce costs and improve efficiency. So in the mix of all these things that we are discussing, what is the role of technology? Each aspect of the fourth industrial revolution has a great impact, has a great role to play in the mix of things. And focusing on the oil and gas industry, a lot of transformation is happening, applying cutting-edge technologies in the areas of seismic, drilling, exploration, and production, with the objective of improving operational efficiency, providing real-time data, and using this data to increase revenue, cracking this data in order to make real-time decisions, okay, to increase safety, as you'll be seeing in few slides, and of course to decrease risk in our workplaces. Now, in the next few slides, I will be sharing with you some successful use cases, okay, with the objectives of either some of them are helping us to reduce operational uncertainties, to remove human bias in our operations, and of course, to remove the errors, because where humans are involved, there are high probabilities of committing mistakes. And in that category of the use cases, I will be talking about how the outcrops are being automated, how the core description process is being automated, and how the thin section analysis is being automated. Also, I will be touching on some use cases that reduce operational costs, manpower requirements, and also time requirements. In this area, I will be sharing few examples from how wireline logs are being used to estimate various reservoir properties, and also how some missing information are being filled by using machine learning. And an example is porosity, and also how the time value of all this information are being increased by focusing on how the reservoir properties will be estimated at the earlier stage of reservoir development. Now, in the area of seismic data acquisition, nowadays, the manual geophones that are dropped at certain places are being replaced by drones. Okay, and the acquired data are being processed with various algorithms, and they are being interpreted by leveraging on technologies like the convolutional neural networks. And I'm very sure the subsequent presenters, Mr. Destiny and Olawale Ibrahim, will be going deeper into these application areas. Also, outcrop mapping that traditionally will require a number of geologists to go to the field, okay, and then trying to describe the outcrops. Nowadays, also drones are being used, okay. So the drones will acquire the high definition images, which will be processed by photogrammetry technologies, and then they will be converted to outcrop models. So that will actually help us to practically bring the outcrop from the field to the desktop, and you can manipulate, you can actually, the things that you cannot do on the field, you can actually do them on such models right on your desktop. And this technology itself will reduce the risk of geologists falling off the cliffs and so on. It will reduce the need for travels to the field, and even the number of people involved in outcrop mapping will be reduced significantly. The core analysis is being automated. Actually, this is one of the first projects I worked on when I joined Saudi Aramco. So this reduces the human subjectivity in the core description workflow. It reduces the time it takes a geologist to do the description. So all these things are coming together to improve efficiency. And also the thin section analysis, I was involved in a project that that uses image analysis and image segmentation, algorithms, classification, and of course CNN to automate the thin section analysis, and all this with the objective of reducing the human bias that is associated with these workflows. And also, as I mentioned in the Archie equation, one of the inputs that is required to estimate water saturation is the exponent M, which is the cementation factor. M itself, in that, to keep that equation simple, the value of M is sometimes assumed. Sometimes it is assumed to be 2 for a carbonate formation. Sometimes you have a few values obtained from the laboratory measurement, and then you take their average. So, but it has been proven that instead of using a constant value, or I mean, either coming from the average of laboratory measurements or coming from an assumption, it will actually be better to have a log of this. Having a log of this from the lab is not possible. So you use machine learning to derive a log of this cementation factor in order to plug them in to the Archie equation. And the same thing we do for M, we can do for A, the tortuosity, and the N, the saturation index, before having doing this will give us a more realistic estimation of water saturation. This is, using machine learning for regenerating methane logs, and I feel proud to mention that Mr. Olawale Ibrahim actually worked on this, and he made a presentation in it last year in a conference in Nigeria. Now, I call this real-time reservoir characterization. Currently, most of the reservoir properties are either derived from core analysis, which takes a lot of time after drilling to obtain. To make them closer, they are derived indirectly from wireline logs analysis. Now, I have, done some projects, and I feel proud to report that I have been able to establish a correlation between mud gas data, which is one of the data that are acquired while drilling is going on, and some reservoir properties like porosity. So the example here is that of porosity, and the R squared is up to 80%. In fact, one of my clients told me that if I have a model that gives me a reservoir property like porosity, while drilling is going on and it is 80% correct, it is good for me. I'll just go with it and I can make a lot of decisions with this. So apart from porosity, I've also used the same approach to establish a very good correlation between mud gas data and the hydrocarbon volume fraction. So, and all this, instead of waiting until wireline log is acquired and then they are analyzed, or waiting for core analysis, we can actually get these same reservoir properties while drilling is going on. And I'm trying to apply the same methodology to more reservoir properties, such as permeability, saturation, and so on. So all these are possible by applying machine learning. Now, Hall is not, despite all these successes that we have achieved, there are still some challenges, okay? There are still some challenges. To apply machine learning, we require substantial amount of data. A few clients have invited me and they want to apply machine learning. And when they showed me their data, sometimes they showed me data set of less than 10 samples. Can you imagine that? Less than 10 samples. And they have interest in applying machine learning. So I simply tell them, I'm sorry, with this amount of data, we cannot do machine learning. Okay? So one of the challenges we are facing today is that people want to apply machine learning, but they don't have enough data. So I see this as a challenge. And then the learning process also requires a degree of expertise. Some people, erroneously say that, well, machine learning is all about, getting a bunch of data, split it into training and testing or validation, and then just apply some algorithms. It is not as simple as that, okay? To have a model, you need to avoid under training, to avoid overtraining, overfitting, underfitting. Coming up with a model that is robust is not easy. So it requires a degree of expertise, and not anybody can do this. Another challenge that we're having in the industry, in the machine learning application, is what I call the black box phenomenon. Some domain experts nowadays are still saying that, I cannot use a model because, I don't know what goes on inside it. It's a black box, and so on. But I usually, argue this out by saying that, each of these machine learning algorithms that we apply, they have established mathematical basis. They have their foundations in mathematics and statistics. So they are well established. For example, there is a textbook on neural networks that is 600 pages. All these 6 pages are saying nonsense. They are rather establishing the mathematical basis. And types of neural networks, algorithms, is establishing their basis mathematically. So it is actually not true. It is when you don't understand what goes on in something, then you say it's a black box. To us, since we are in this field, we know that they are not black box. So we have a lot to do in this area to overcome this black box phenomenon, which I see as a challenge to machine learning application. Also, some domain experts claim that, what these machine learning models do is just to focus on only the data, and they don't consider the physics of the problem. But I say, but the data is actually a reflection of the physics. For example, in the work that Mr. Palawale Ibrahim is doing, for example, predicting reservoir properties from wireline data, okay? We talk of gamma ray, we talk of neutron porosity, we talk of density of the rock, and so on. The logs that we derive from them, that we use in our models to build our models, are actually a reflection of the physics of the rocks. So this is not true, but I see it here as a challenge, because we need to explain this to domain experts in order to be successful. Because if we build a model and the domain experts refuse to use it, then it is not a success. Another challenge that I see here is that some data scientists, they lack fundamental domain knowledge. This actually applies to me. As we must have heard in the in my citation, that all my degrees, first, second, and third, are all in computer computer science. Then you might ask, what the hell are you doing then in the oil industry? Well, I found my way into the industry through the machine learning application. And I can tell you today that I am using every single project as an opportunity to learn. So now I feel proud to say that I have acquired some knowledge of drilling, some knowledge of exploration, some little knowledge of seismic, and so on, based on working with the domain experts in applying machine learning. And as you will see in the next slide, it's actually one of the ways out of this challenge is for data scientists not to assume that they know the domain knowledge sufficiently enough, except you are a geologist yourself, or you are a petroleum engineer yourself, and you are also well, established in machine learning application. Then you can be two in one, then do it to a better. I always say that there is a difference between someone who took a few courses in Coursera or in Udemy and so on and becomes a data scientist, and someone who passed through different levels of computer science as a course. There is still a difference between the two of them in terms of depth and breadth. So now I come to recommendations. I think I'm getting close to the end of the talk. Now, how do we overcome some of these challenges? And indirectly, it's saying that, okay, how do we move forward despite these challenges to continue to record more successes and to continue to bring, innovations into the industry in terms of, from the machine learning application. The first one is to invest massively in data acquisition, and this goes to the industries. Actually, this goes to the industry. Some of the legacy tools and machineries will need to be changed so that the data so that we can get more data in terms of quantity and quality as well. So we need data both in terms of quality and in terms of quantity. We need that for a successful machine learning journey. Also, we need to seek to understand machine learning techniques, that is whitening the black box. It is just not enough to invest in data science, but we should rather invest in the foundations of these machine learning algorithms. We need to understand how they work. By doing that, we'll be reducing the black box phenomenon, hopefully, and that will result in domain experts having more confidence in the models that we build for them. And also, data scientists with little knowledge of the domain of knowledge need to work in collaboration with experts in the field to inject as much physics as possible into the models that we are building. So this is very important. And also, and I think this is very important, many people see, machine learning experts, some of them learning as just a matter of training, testing, and that's all. No. If we continue to go with this notion, then the rate of our success might be very slow. We need to come up with solutions that rather include machine learning in them. So instead of presenting individual solutions, okay, we use machine learning to predict porosity from wireline data. We predict permeability from wireline data. We predict hydrocarbon fraction from mud gas data, and so on. Okay, the question is, before then, what do we do with the data? Also, after that, what do we do? With the result, you should bring all those things to the solution to build, instead of building, training and testing models, we should rather build solutions that include data acquisition and also how to further use what we are predicting. I mean, how do we use them? What next? What comes after that? So we should put that into the table and not just presenting machine learning as limited to training and testing only. We should rather build, instead of building models, we should build solutions. That's the essence of what I'm saying here. And also, we should build, rather than individual solutions addressing narrow objectives, we should build integrated solutions. Okay, we should build what I would call suites of solutions, sometimes called one-stop shops. For example, let me use the Archie equation as an example here. Instead of having a model or a solution predicting the M, which is the cementation factor only, another model to predict A, the tortuosity, another model to predict N, the saturation index. Why don't we have a suite of applications that from the input, okay, you get the A, you get the M, you get the N. The same application suite, the same integrated solution will plug in this AMN into another set of equation to predict water saturation. So at the end of the day, you come up with an end-to-end solution instead of narrow individual solutions. So I want this to be a takeaway for the students and for the young professionals, as we are acquiring hard skills from AI, from machine learning, from robotics, from blockchain, from various events like the one that we are having now, the GeoPython and other platforms. We should also focus on the soft skills. Soft skills are equally important to ensure the success of machine learning applications. For example, in order to bring solution to the industry based on machine learning, you need to have what I call algorithmic thinking, okay? And the way I explain this is that you should believe that all problems have solutions. To say, oh, this is impossible, I mean, impossibility must not come into your vocabulary. All problems have solutions. The solutions might be difficult, they might be tough, but to say there are no solutions should not be there at all. So that is number one. Then also, if you have this problem solving skill, you should be able to, visualize a big problem and then dissect the big problem into smaller problems and then attack each of the problems one by one. You should be able to do this. Then to bring solutions to the table, you usually work on projects. So having a good project management skill is very important. And also resilience, not breaking easily. Sometimes you build a model and it doesn't work. You want to give up. Don't give up. Don't give up easily. Continue to find ways to make your model better. Continue to explore different means to make your model work and so on. So this is very important. And bringing both the hard skill and the soft skills together is what will bring technological innovation to the industry. So I will conclude at this point. I have given you an overview of what AI is all about, and I've zoomed into machine learning and the various methods under machine learning. I touched very briefly on the supervised and unsupervised learning concept of machine learning. I discussed the requirements of machine learning, when exactly to use machine learning with few examples, and I gave a few successful use cases. Of course, I presented a number of challenges, and I recommended a few solutions. And I hope that this piece will be of great benefit to my audience. I hope that this will, further assist you as you go further into the journey of machine learning, and to help you as you look forward to making big impacts in the industry, and to keep the production of energy safer, making it more efficient, and making it more productive. So at this point, I will say thank you very much. And I hope the organizers have shared the link where you can post your questions, and I'll be glad to address your questions. And while taking the questions, I'll be glad to, if anybody has any concern, or if there are any questions that I won't be able to answer at this time, feel free to contact me, and I'll be glad to attend to you. Thank you very much. Over to the moderator, please. Thank you very much.
Thank you so much, Doc. That was a very insightful one, sir. I don't know if you'll be able to take some questions on Mentimeter now before we
Yes.
before we bring in Destiny. So maybe you would
Yes,
have
please.
to
Let's go ahead.
grab in your Mentimeter screen.
Okay. Yes. Yes, I have a few questions here. Let me open them. Okay. I have a few questions here. So will you go over them, or I should read them out myself? Oh, okay. Sorry, I have it on my phone only. Yeah, I have, I have it open on my phone rather, instead of being on the system. Okay. Very quickly, the first question on the list here says that do we also need to learn backend like Django in order to deploy our machine learning models? Very quickly, I would say that actually the tools that you need, or the platform that you need, will depend on your working environment or your deployment environment. Some environments don't require any of these high-level backends. Some are as simple as just compiling your software and just deploying on the client computer. I mean, some environments are simple as that. In some, you have to deploy on some cloud infrastructures and so on. So I would say that what you need to deploy your machine plan would depend working and in various opportunities do that. Oh, someone is asking what is the topic of my lecture. Okay, he or she probably missed the beginning. The topic of my lecture is actually the machine learning application in reservoir characterization, the pitfalls, the challenges, and recommendations to overcome them. So this is the topic. The next question says, will AI and robotics take over the oil and gas industry? Well, I don't know what you mean by taking over. If what you mean is that replacing all the human beings there, I think the answer will be no. There is nothing like the AI or machines taking over any industry. In any industry where machine learning is being used, whether it is robotics or whatever, human beings will still be at the center of those applications. However, the number of humans might be reduced. Okay, so the number of human interventions will be reduced. The number of involved reduced. And if you ask me, is that a problem? I would say no, because I am glad to say that I was part of the computer revolution. When I was working in OAU, there was this fear that the computers will render the typists and the secretaries jobless, because the HOD or the director, they will begin to type their letters by themselves and so on. Even though it almost happened, but the typists had to reskill themselves. So the solution to this fear that machines going to take over some jobs or to reduce the number of people on some jobs, the answer is yes. And the way out is some people will need to reskill, because there are still some areas that machine learning doesn't work up to now. So some areas will see that machine learning, robotics will not work. So those areas will still be manned and handled by human beings, okay? Or until machines take over eventually, human beings will still be in full control. So I also address that question. The next one is what level of understanding of algorithms is required to be a machine learning engineer? Well, as I said somewhere in my talk, it might be enough in some cases to just be a data scientist. That is, by knowing how to use some algorithms to address some problems, to achieve some objectives, like making predictions, making estimations, and so on. But actually, each category of people have different roles to play. So data scientists have their role to play. Statisticians have their own role to play to help us make sense of the models and their performances. But we also need computer scientists. We need mathematicians to help us in making people understand the practical foundations of all these algorithms. So it's actually a teamwork. It's a teamwork. So everybody has a role to play in the entire workflow. The next one, what is the difference between machine learning engineer, data scientist, data analyst? This is very interesting. The difference in them is actually derivable from even the titles themselves. A machine learning engineer is someone who engineers machine learning algorithms. It could be that they are involved in collaboration with the mathematicians and the statisticians to create new algorithms or to find opportunities for the application of those algorithms. Okay. Scientists work with data, okay, making sense of data, trying to understand data, cleaning the data, trying to find correlations in data, and so it's all about data. Then data analysis analyst, from the title itself, they analyze data, again trying to find correlations. So sometimes at a point you think all these titles are just one. In some companies, in some places, only one person does everything. While in some other places where there is so much structure put in place, we have different people playing different roles. So it all depends on where you find yourself. I mean, in the environment where you find yourself. Please let me know when it is time to stop the questions, but because they keep coming. The next one is okay, fine. Okay, 4 minutes. Okay. So the one says, is feature engineering a subset of machine learning? It's actually not a subset. Feature engineering is one of the knowledge discovery process that I mentioned in one of my slides. Okay, it actually came in between data selection, processing, and data transformation. So it comes in within that range of activities, and it's basically is a way of creating more features where you have a short, or feature selection when you have too many features, you want to scale down your space in order to have the model and so on. So it is not a subset, rather. It's rather one of the knowledge discovery process of machine learning, not a subset. Okay, so what is the cutoff in data size that I can decide to use neural networks or SVM or John tree, or we try it all with monitoring the results? Well, I would say that I mean, what I do with my own clients is that I tell them, please give me as much data as you have. I don't have a cutoff. If you have millions of data, bring them to me, because the more the data you have, the better. Even if for the shallow models, even if they have to play to or to pick at some point, having more data is still better. I wrote a paper. If you go to Google Scholar, type my name there, you will find one of my papers. The title is How Much Data is Enough? Okay, how much data is enough for machine learning? There, I did some experiments and I came up with something around 200 data samples. But as you know, it will be subjective. Perhaps it is subjective to the kind of data I used, which is oil and gas data, wireline data. If you try some other data, it might give you a different value. So I would say that there is really no cutoff. So whatever you have to use. But know that the more data you have, the more confidence that you will have in your model. In 1 minute, let me quickly address the next question. How do we do simple to complex computations using Python? Well, the subsequent presenters will handle that. Mr. Destiny and Mr. Olawale Ibrahim will be taking you through such details in Python programming and machine learning applications. So in half a minute, let me also take one more question. I also learned you can do a 3D modeling of the reservoirs using a Python. How can you do that? Well, again, the subsequent presenters will go deeper into that. But the question is, yes, you can. Python is actually a very powerful programming language. It's a very good tool, and but know that it is not only about Python. There are actually so many languages out there that you can use, but Python seems to be the most popular maybe at this time. Some use MATLAB, but we all know the problem with MATLAB. You have to buy the license, so it is not available as a open source. Also, there is R. Also, there is there are many tools. There are many languages that you can use. So it's not only about Python, but Python is a very good one at this time. So I think I will stop here. Time is fast. So please, as I mentioned, you have my contact on the screen. I'm available on LinkedIn. I am on ResearchGate. I'm on academia.edu. And also feel free to send me email if you have questions that I couldn't address, or if you have anything bothering your mind, I'll be very glad to attend to you. So over to the moderator. Thank you very much. Okay.
Yeah, I'm here. I'm here. Thank you. Mr. Um, Mr. Fatai. I listened to your lecture. Thank you so much, and thank you. Okay, do I have to put on my video? Okay, I really am not in a very, should I say, dispensable environment, but let me try. Okay.
everybody that's Destiny Otto on the screen is a Python developer, and also the technical lead of TechPet Global is someone I look up to so much, and it's a pleasure to have him on this Joe Python week. You're welcome, sir. So you can share your screen and do your thing.
All right. Thank you, Adetola. So let's go straight to business. Okay. Is my screen visible yet? All right. All right. I guess it should be now. When it is, just let me know. All right. Thank you so much, Mr. Adetola. Thank you very much, Flossgate organizing team. All right. So it's my pleasure to really be here today. And thank you very much, Dr. Fatai, for I really love the clarity, sir, with which you presented everything. All right. So I will just go straight to my session. So basically, I had prepared a session on petrophysical analysis with Python. And I'm going to be taking, I'm going to take you through, should I say, the basics of using a matplotlib, visualizing logs with Python, well logs. And I hope to go as far as doing some petrophysical calculations, and then doing what we call exploratory data analysis, right? In doing machine learning, EDA is exploratory data analysis, EDA. It's usually the first step, right? Data scientists do that a lot. And ever before you start talking about building your algorithms, using selecting a particular algorithm, or before you talk about your feature selection or feature engineering, you will need to do what we call, for most of the times, you need to do what we call exploratory data analysis. So I'm going to be going through that hopefully in this session. So if you permit me, I will just leave my video turned off while I go on, right? Thank you. All right. So I basically don't come with prepared notebooks, right? Because I feel it's more interactive and interesting. So I just code from scratch, right? So and then what else? The backside of that is that there's likely going to be a number of times, not just once, but a number of times we are going to run into error messages and error pop-ups, right? So, but we are all working together. So if there's a way, I would have really loved it if there's a way you could quickly point out to me, oh, there's an error you didn't see there, right? But unfortunately, I don't know. I'm not. The audience cannot interact directly. So I usually love it when you can speak, when the audience can speak to you directly, right? So let's start with kind of loading data from. I already forwarded a number of data sets to Adetola. I'm sure he has passed it across to you, right? So let's start with loading data from into my Jupyter notebook, and then I'll display the data using Pandas. So let's start with Pandas. I'm sure you already have Pandas installed in your system. Sorry, Panda. Yeah, you already have a Jupyter notebook, or if you're not using Jupyter notebook, whatever editor you are using, Panda is already installed, and Matplotlib and NumPy and some other libraries I will introduce as we go along the way, right? So we are going to be using these three first. NumPy. Okay, let's start with this. I'm going to introduce Matplotlib much later on, right? Okay, so I use this as a markdown, right? So yeah, I can hear you. I didn't get that. Okay. So, but let me just quickly do this with this. All right. So, all right. So just give me a minute. I need to do something first about my display. All right. Is it any bigger? All right. All right. Sorry, just a second again. All right. Let's go on, please. Okay. So let's go. Yeah, let's go on. So let's quickly go on. So basically, as it's almost become a custom whenever we are using well-log data to use the name variable or maybe data, just data, right? So I'm going to use the normal pandas.read CSV, and then I'm going to read the name of the data. I think that is that should be data 3.csv. I hope I got that right. Let me just confirm that. Okay. Wow. Okay. Let me use Neptune data. All right. Let me use Neptune data. Sorry, Neptune. Yeah. Just to confirm. All right. All right. Okay. So that's done. And moving forward. I didn't get you. You're still not saying it. Wow. All right. Okay, so let's go on, please. So we have let's move on. Sorry. So I've read did I not get that spelling? Neptune data.csv. Hope it's in. Sorry. All right. I don't know if that particular file was here. Let me just transfer this to another file. All right.
Use quotes around the file name.
Huh?
Use quotes around the file name.
Oh, that's
Sorry,
true. That's true. That's true. Sorry. All right, that's true. So let's move on, please. All right. I'm so far away from here that okay, let's go on. So that is 4. So we can display the data here. And we could display the head or tail, but basically just looking through the data, we could use this pandas method described to actually see the statistics of this data. And then looking at them, they are mostly the same, okay, except maybe this one and okay, I think this one. All right, they are all the same. Or it's like one. Oh, they're all the same. Fine. So probably I will use another data when we get up to somewhere. I wanted to display the how you could use the replace function, right? So particularly when you have data, when you have missing data points, and or when you have wrong data points, having .99, we'll get there anyway. We'll get there, right? So, but let's move on with this, right? So with this, you can see the maximum and then the minimum data points, right? And then going forward, the next thing I want to do is I just want to go straight to, okay, of course, you know how to use this. These are pandas functions. You want to display the head like 5, or by default, it shows the first 5 rows. And then if you want 20, the first 20 rows, you can use that. And then this tell the last 20 rows, right? And moving forward from there, moving forward from there. So you might want to just create a kind of a very simple plot without using matplotlib yet, right? So you might just want to with a pandas function called .plot. Yeah, so you might want to plot this depth and y equals to let's say GR, right? We have GR on this table. Okay, good. So if you do this, you have a simple plot of just to visualize your data, right? Moving forward, you might want to do this popular cross plots that that we do in plotting ROHOB density plot against neutron plot, or neutron density cross plot as we know it, right? So it's just the same thing. It's just the same way, right? Maybe all you just need to do is is to specify the x and the y. So, but this time around, I'm going to be using a scatter plot. So I'm going to say type equals, or rather kind, it's scatter, right? And then I'm going to put the x to be MPHI, that's the neutron log, and the y to be ROHOB. So with this, I could display a kind of a plot of neutron against density, right? I could actually put a limit to the y axis. Let me say 3. Let me say here we have 1,500 and 3,000. All right. So moving forward, another thing you might want to do is just to show you some of the most popular things or common things we do when we are doing data analysis with Python, right? And in this particular case, I will be talking about well logs, right? So so still once again, we might want to add use color, right, to differentiate or to identify maybe shalier and the cleaner formations or intervals, right? And you might want to use a color map, a C map, right? So that is where we'll introduce that here. We introduce that here, right? So okay, so I think I could just do this here. Okay, and then moving forward, you just need to introduce the C. Okay. Yeah, for the gamma ray log, and then you use the color map, right? And that you could use any of them. There are a number of them. Blues, jet, quite a number of them. This jet is just one of them, right? So going from there, if you plot this, okay, got an error there. Did I write C without writing? All right, what's happening? Yeah. Okay, good. So this will help you. Of course, this will help you to at least visualize and to see the regions where, or the places where you have shalier or cleaner formations, right? So another simple thing you might want to do to look at your data. Let's say, for example, you want to plot maybe GR plot against. We want to just see a kind of a histogram of the data, the nature of the data, right? So this is could use any of these here, hist or bin or bar rather. Yeah, so if you use shift and tab, you'll see quite a number of the arguments that could go in here, right? Look at them here, line bar and the histo box, KB, that's the kernel density estimation and all that here, right? So using that, let's use histogram. Okay, so just using this alone first, you plot a histogram, and then bin, if you want to increase the size or reduce the size of the bin, right? That's a 20, right? So moving forward from there, these are just some of the simple things you might want to do even before we start moving into matplotlib. Already you can read a file, you can manipulate data with pandas, right? So it's just going to be the same way as you do. It's just going to be the same way as you do, as you would normally do data from with in any other case, not just geosciences, right? So the next thing I'm going to do is to go into matplotlib. But before going into matplotlib, I'm going to let me start by, okay, I might want to go to the top to do this, but let me just put it here. Right, matplotlib.pyplot as built in. All right, so I want to also show you at the same time how to read files from LASIO, or maybe that, okay, that should come in later. We'll still go ahead with this particular file or this particular data, right? So again, if you have this data, I just want to, let me just do something. I need a file with a data with at least minus 999, or I don't even need that. Let me just assume that the point I have from data. Let me just bring up my data first. The head 20. Let me say at some point I have some data here that is not good, right? I don't even know the name of the particular data that I I used for, I kind of forgotten the name, right, for this particular one, right? So, but I wanted to just show you how you handle, but I believe we'll still get to that, particularly when we get towards the EDA, right? So, but let's just move on with this. Right? So let's say want to plot. Let's say want to plot the normal. How do we call it? The triple combo, right? The triple, or any three sets of subplots of any three tracks, right? Any three of the curves, right? and the way we are used to it, right? So all we just do is use the matplotlib subplot, and we just use this fixed size. This will give you the size of the plot. So let's go with 2020, and moving forward, the next thing you want to do is to set up. I just want to assume you are used, at least you have, in a way, you have gotten all this, you have come across all this at some point. But even if you have not, just to make sure people who will be going over it for the first time are not entirely lost, right? So I'll just keep going slowly, right? So this first argument here shows the shape you intend, and the second one shows the position, the position on the grid. Then okay, let me start with 0, 0. Okay, then okay, that could be all. Yeah. So the next thing is just, since they're basically gonna be the same thing. All right, so all I just need to do is change this to 2, change this to 3, and change these positions to 1 and 2, right? Okay. All right. Okay. So the next thing will now be to to do the actual plots. So basically, you just use this function to do the plots, ask on the plots, and then let's start with, let's say, the gamma ray, and then we have depth. Then we get the data source will actually be our well, which is our variable for our data, and we might want to give it a color, right? So let's give it what color do we give it? Red, right? Okay. So that's basically this in its simplest form, right? So all right. Right, so here we go. Let's give it this. So all I might just need to do is just to say ax one.grade. Okay. Ax2. Same thing. All right. So this basically is the visualization of the log. So let's put in others here, like the ROHOB and the MPHI. That's the neutron plot. So this is your plot. These are your plots. Could reduce or increase the size here, right? And let's put in other things. Let's just add some other things to plots. They are looking there, nothing written on it, all those labels and the title, and maybe if possible, like for this one, it seems to be skewed to one end. Okay, I guess that's because of this spike here, right? Okay, let's see if there's anything we could do about just adding some extra features too. So for example, let's start with adding title. And then we'll do set title. Let's call it, I think the first one is gamma, right? And then that's it for that, right? Then if we want to kind of limit either the X or Y axis, if we want to put limit the scale, right, in the X or Y axis, you use the Y lim function. But I think I'm satisfied with the way it is. I will not want to bother limiting it, but this is the function you use. So I'm just going to put it here for the S limit, right? So let's say we have 0 to, let's say we have 0 to 200 or 140. So you could see this here, and then you could do the same for this other two if you feel so, which I will just keep all this. They are all basically the same. Just repeat, just repeating this, and let's quickly drive to somewhere I would love us to be. Then the second one is the density, right? Okay. And then the third one is neutral. All right. All right, so basically these are some of the things you can do, right? You could use the Y lim or set X lim or set Y lim and all that. So there are some few more customizations you could include in your plots, right? There are some few more customizations. Let me just see how we could do that, right? In the next, here I'm going to, let me just copy some of these. So I'll not be using most. Yeah, the next I'm going to do, I'm going to plot the maybe I'm going to bring in the sonic log. I hope we do have sonic here or any other log, right? But I'm going to plot the ROHOB and the MPHI on the same axis, right? So just watch how I do that, right? Just watch how I do that while I try as much as I can to explain it. All right, so this is generally the same, but I'm going to bring in the fourth one, which I'm going to bring in the twinning function or method, right? Which is going to form it's going to be the same with this one, that is going to be on the same axis, right? So this is basically what you introduce, right? And then I'm going to go forward to begin to write the plotting code, right? So let's go ahead with this. So if we say at1 the plot, and then we use GRO as usual, and then we bring in the depth. Okay, we bring in source of the data, and we say our data is of course well, and then give it a color. And okay, we are starting with gamma. This time I'll give gamma a color blue. I'll have to give them different colors. Okay, let me not just give randomly. Let me say, okay, blue is fine. I want to use red and blue for neutron and this thing. So let me use green, right? So moving forward, I'll use next I'll do it. Let me just set the label. I also need to set Y label too, right? So which will actually be depth, right? Okay. All right. So call this depth, right? So that basically is It's all I need for that gamma log, right? So at a point, I will need to introduce what we call the spines, right? Which is what you usually see at the top here. Okay, let me just do that at once here, right? Let me just do that here. So if we say as dot so I'll introduce that here and I'll position it at the top, right? So yeah, so and then I could even put an edge color, right? And still make it green. So before then, I will need to bring in this function that we use. You have to use it to specify the particular place where this span should be, right? Is it the X or Y axis, right? So okay, so we have axis and X. So again, you give it the color, still give it the same color, green. So with this, I just need to, what else? What other features do I need to put? Let me just put in, okay, let me put in the values that should actually reflect on the values that should actually reflect on the spines. So we have 0, that's for this particular measurement. Let's say 0, 50, 100, right? So that's fine. All right. So this should be more than enough. This should be a list, right? Okay. Okay. This is supposed to be set edge color. I don't know why I didn't do that. All right. So this basically it's for our gamma log, right? And the plot, don't worry, the plot will come in, right? If it gets to a point where I'll need to use a for loop, sorry, the features will come in. Let me just get to the point where I need to use a for loop, right? So I'll just use this and just create the other 2 or 3 logs, right? So this will rather be, let's call this the second. Okay. Right, and call this the third. All right. So all right. So we'll just do this for, let's call this for NPHI, and let's call this for okay. Let's say for okay. Let's call this. Did I get sonic log here? I don't think I did. Or let me just use which one am I using? Let me use the T. All right. So yeah. So then I could change this color to red. Okay, no, that's for this. Right. So that's for that. This red, and this for this. This let's change all the colors. Let me make this yellow. Or is it purple? Yellow. All right. All right. So we'll still have to do some adjustments. For example, this is okay. Let's start with no, let's start with RHOB first. What is wrong with my com? Then let's call it. All right. So this should for density normally between. I hope my density is normally between. Have I plotted here for? The values from this log data seem somehow different, right? Normally, a log is density log is really 1.95 to 2.95, right? So, but I'll just leave it this way, right? So you could use that as your sticks, right? All right. Okay. Okay. Let me go with this. Okay. Let me just set. Okay. All right. So hope I don't get anything wrong. Let me just say like 1.95. If I don't get this right, it's gonna say 2.45, 2.8, 2.45, 2.6, right? So, and then we have 2.95. Right. So for the last one here, all right. So I want to believe I'm done with not placed any limit on any of them. Okay, I'm done with that, and I will need to finally give the last track because I left it because the neutron, because it's going to be placed on top of the density plot. Right. Oh, all right. So let's do this. Right. So this is in the fourth axis, but actually on top of the second axis. So we use that plot, and then I'll call this the NPHI, and then I'll use the depth just as every other chart. Then let's go to putting. We are given this a red color, right? So this should be blue. This should be blue. Yeah. All right. So so the next thing I want to do, okay, I think I can just go with this instead of writing them afresh. All right. All right. So but from here there will be a little or a slight difference. So neutron. Right. Right. So okay. So from here I will just introduce the I'll just introduce this. I'll use X limits to actually lim to actually limit the scale, right? So it's normally from 0.45 to minus 0.15, right? So basically, I hope that it's fine enough. Right, so that's for the MPHI, right? Good. It seems I don't know the units in which this particular log data was measured, but don't worry, it's no problem. All right, so let's quickly introduce the spines at this point. So so I'm going to use this first as I did the other time, and I'm going to yeah, do this as I've done, and then I'm going to put the colors of the spine, which of course will be blue. So the next thing is to put this in place, right? Right, and then I'm gonna use this to put that in place. Put this in place, yeah. Okay, and then it's gonna be here, and okay, I'll come back to this. So the next thing is just to do the same thing. Okay, I could stop here and just visualize it to see I'm not making any mistakes. Okay, so there's it. Again. Okay, where have I used position? Oh, sorry. Okay. All right. So, okay. I guess this is where the problem lies. I have to put in this value here. Okay. 0.08. Set position text group. All right. Okay. So maybe I had given it this. All right. All right. So this is the neutral and density plot. Right. So this plot is somehow for the we are still working on this, so just be cool, right? Sit back and relax. We're still working on this. Okay, so you can see this here, right? So let's keep moving. We are not there yet, right? We're not there yet. So I want to use a for loop at this point to actually put some things in place. So if you can't just follow me, right? So so for both as1, as2, and as3. All right. So let's do this. So we have we'll first of all set a grid, right? And we'll just use this to set this to major, and we'll use this to specify the color. All right. And we might want to specify, okay, I think we can stop here, right? So moving forward, we might want to specify the position for our ticks, our set ticks position or function, right? So this is how you do it, right? So you just do it this way, and then you do this position, right? And here you specify to be. Once you have done that, you could still do this for the labels, right? So we're going to bring in the labels here. All right, good. Apart from this, I think we are okay. Let's work on the spines a bit too, right? All right. So yeah, and we can set the position to be the top. Right. Good. Right. So, all right. All right. So, with this, I can think I could just go ahead to use my PLT here and use a tight layout. Right, and do this here. All right. So, just to ensure I have not made any mistakes before running. Okay. All right. So I should have used this here. Spelling. All right. So you could see that I have you could see I have this here and I have this here. I know some persons may have questions and I'm really concerned about that, right? So, but I don't know, is there a way to take the live questions from the YouTube, right? So, but let's go on anyway. Okay, all right. Okay, it's not open now, right? I don't know, but I'll check it. I'll check it. Let me just let's just try to move from here. So I think with this, you are done with this, right? I know you want to see you might really want to see this neutron density, crossing and all that. You're going to see that, but it's also depends on the data set I used. Right? You're going to see that in my next I think in the next block now. I'll I don't know. It seems okay. Let me check. Let me check if I could quickly go through the questions in the Mentimeter. It's not open now, and I don't want to. It's not open. Okay. 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 It said how to put all color maps in a list, right? So basically you we'll get to this point, right? Don't worry, don't go too fast. We'll get to this point. So I'll show you how to do that, right? So it's part of what I'm going to show you, right? So I guess that's the only question. So, all right. So all right. So I'll move to I say at the point I say I'm going to show you how to import a last file. You have a last file maybe from Petrel or somewhere, and you want to bring it in here, right? So the procedure is simple. So I'll just call this my last file, and I'll just say lastio.read, right? And then so already you have imported lastio because yeah, because you have installed lastio I believe I sent it, right? So that's fine. So let's just go on with this. So for this particular data, I think it's well 3 dot last, right? So that's it. Okay, so let me just confirm. Okay. All right, that's correct. Not imported it. Okay. Oh, all right. So basically I've imported that, and let me just quickly, I don't know. The next section, I don't know how long. It's 1 hour, right? Next section. It's 1 hour, right? Okay. Okay, so we can take the break now. Then 5 minutes, sorry, 10, 15 minutes, right? So all right. We can take the break now. All right, thank you. Can I go on? All right, so before moving forward, if you check here and there happens to be any issues like here, you could see only one value here. It's just basically from here, your S sticks, right? So you just come here and change the values to what you want to appear there, right? So that's just it. So you can do that to yours. So for me, I'm really under time, heavily under time constraints. So I'll just be moving forward with other things, right? So so I have this file here, this LASIO file, which is actually a LASIO file. So I've imported LASIO and I've read the file, right? So the next thing I want to do is that I want to put in a form of a data frame, right? So I'm going to call this, let me just call this data, or maybe, well, okay, no, let's use data, right? So I'm going to say, that's this last file .gf, right? So putting it in this format, puts it here. So this is basically how it looks like. And let me just use, let me add a column. Let me add a column, which I'll call, right, as an index. So, yeah. With this, I could display this again, and the depth has been added, right? So moving forward, plot, right? So let's move on with that. So generally, if you want to make a mass plot loop simple, I would have started from here, I guess, right? So it's just to use, if you just want to make a simple plot of a log, right? So you could have just done something like this, maybe, maybe data dot logs, and then you use the X. Let's use the GR, for example, and then we use the Y as depth, right? And you could use any color. So let's say we are using black, and that should do it. Could put in your fixed size. I just want to use this to show something, please. I'll say for it. And so with this, you can move forward to, let's just add something like a title before we use plt.show. And in here we're going to put gamma plane plot, right? That's without any color or anything, right? So using, so you could see the adjustments here. Then going forward, of course, you can increase the size if you like, 710. How you might want to use this function we call the field between X. Then you have to specify this and the particular column from step by step. You want to color the background, it's almost the same syntax that. So let's go on, right? So I'll just give it a fixed size of let's say I always use 7 and 10. All right, so this should do, and then I'll define the first axis to be BLT.subplots, subplots to grid, of course, and then the first one is the size. The second is the position on the grid, and you can stop there. So the next one will just be a twins of this one, right? Twinning of the ax one, right? So because I'm plotting both on the same axis, remember. So I will just let me just go down and pick up the same code. I'll just show you where the difference lies, or where you need to make the input, the extra input, right? Let me just go there and all right. Seems I have to write. All right, let me just write this whole thing again. Let me just write it again. Right, I'll try to be as fast as possible. So let's go again. So if we do it this way, we have this, and what do we have here? Density. So and then I want to plot this against depth, and of course the data, and then data equals data, because did I use data for this, right? Okay, yeah, I did. Right, so and then we'll give it the red color, right? So from here I could actually use the slim to set a limit for the y and x axis, right? And then could set a label too. What else can I do here? What else can I do here? What is this density? All right. So that's basically it's that for that. The next thing I want to do is action. Sorry about the background. Sorry, I needed to set my background, a lot of noise. Right. So let's quickly go back to this. So what else do we have? We have gotten set labels, and the next thing we might want to do is just to put in the, just a minute, please. Okay, I think going with just a copy of this might just make sense. Oh shit, what happened? All right. Okay. All right, I just need this. All right. Right. So I think I'm good to go. So that basically should do. Moving from there to the next, okay, so one here, one here, one here. All right, so this I could just duplicate it for the second axis. All right. Oh, okay. So for this, I will not need this. I will need to set it on later on. All right. So I think with this, I'm done with it. Then something I want to do, I want to use these two variables for something now. So I'm going to define them as the two for the two columns, right? So yeah, okay. So oh, I've written density to neutron twice. All right. So S1 and S2, I will be using them in a moment. So another thing I will do is that I'm trying to get I'm trying to get and okay, so I'm trying to get kind of an a set of values from the limit of, so what I'm plotting is the twin plots of neutron density. So what I want to do now is that I want to get the limit of the x and the x on this for the neutron and the x for the density on one end and on the other end. So this is what I'm going to do now. Right. So get this. All right. So I can call this y, or better still z, right? And I use this. Oh. All right. Get a slim for from x axis 2, right? So I'm going to do a little mathematics now. Okay. I don't know if you'll be able to follow that, but I think I'll get to the point first, then I'll try coming backwards to explain, right? So let me get there first. All right. All right. So we have Z here. So this for the minimum and for Z, and the other for the maximum. Then from there we can go forward to what else should be here? Okay, we are trying to get. Just hold on. All right, so we are trying to get this for okay. Sorry, please excuse me. I'm busy. Get out. Get out. All right, sorry. So let's move on, please. So we have this for this, and then we have for the maximum, I could use this for maximum, and just to, yeah. So this is this over this, right? And then we have this over this. I think I've used an extra bracket here. Yeah. So this, yeah. This is for this. Oh no, no. Okay. Right. Okay. So that should be here. All right. So with this, I could do this and then B max. Yeah. And then plus MP dot name. I don't know, this shouldn't be amount, but let me just see something first. So, all right? I'm still getting there. All right, so here's where I'll have to specify the color. Okay, but let me just write this same for loop I wrote here. I've written that for loop again, no need to repeat, right? To use this for loop. All right, so good. Okay, yeah. So with this is fine, right? This is fine. I really don't need the green color again, and I really don't need. I don't know if I need this. I don't think I do. All right, I don't think I do. All right, all right. So, okay, it's not giving me what I want. All right, so let me do this. Okay, let me just go straight to add the colors from the colors for this, right? So we have this, and then yeah, all right. So and then we have this. I could use NZ here. What I used here. Okay, I could even move forward to declare or to say where is this and greater than NZ. So basically you do some, it has to interpolate between them and then color green. All right. So oh, I think I've made a mistake. I didn't close this one. All right. Okay. So I'll just for both. All right. Once again, not giving what expected. Okay. So I think I can deal with this. Let me just say. Oh, that's to use. All right. Okay. What am I missing? All right. Let's hold on here. I think it's from my mathematical formula. So x2 minus p max z this over this minus p max z times p max p max minus. I think it's from here. Let's do this. If I put np dot mean here, if I put np dot mean, what do you think will get me? That will get me to. Doesn't get me anywhere. Okay. 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 Oh, yeah, this is x2, right? Yeah. This is x1. Just want to show. Seems I'm missing out something. Just want to ensure that I'm not. Okay. Pick params, axis, x. Okay, set it column. Okay. You don't need this here. So basically, this basically doesn't kill. Yeah. All right. Just a moment. Just a moment. I have to do something about this. Oh no, this is x2 minus np max. Right. Np don't mean x plus. Wow. Wow, my God. Or do I do this? Let me do this. Put this, okay. This is actually not from, so it's not a problem, but let me quickly change that. Let me remove this limit. All right, so what will happen is this. I'll just quickly rewrite these codes again from the beginning. I've probably missed something, right? So I will just start all over again to write that. All right, so so if I write fixed island, right? So right to grade. Okay. So we have 1 and 1, and then we have here 0 and 0, and here should be. I think that's fine. All right, so we have this, and we have this. when I imported the lasso finance. All right. All right. So we have color, right? And we'll stop there. Or we could equally use this 0.5. And 5. 195. All right. So, and I'll have here ask1 dot else level. I'll just call this the density. All right, and then I'll call this the okay. No, let me not use that. Let me use this. Okay. All right, so we have this, and then dot set color. Right, just to put a color to the label. And the next thing I want to do is to use these stick arms. Okay. Okay. Just code everything at once. Okay.
Mommy, I not sent your boom. And which type of drug should I buy?
All right.
What is done now?
All right. So, oh, did I put a mixture of red and blue? This is red throughout. All right. This should do. All right. Just to change this to 2. All right. Okay. And this should be neutron, right? And we could call the name here neutron. All right. So this could be this is probably the problem. Usually between 45 and minus 15, right? Yeah, so that was probably the problem. But I'm not looking back. I'll just keep going forward now. Okay. Just use a consistent color. All right. I think apart from that, every other thing here is fine. Okay. I've changed it now. Set edge color. Set edge color. All right, looks better. Looks somewhat better. Okay, yeah, let's move on. Right. So I just put in this code here and should be ready to. Oh my God, it's still not. It's having to do with the scale. I don't know. Wow. Instead of letting this take a lot of my time, I think we'll just stop at this point. Now we have this. Okay. Right. Okay. We'll just stop at this point. Right. So we'll just move on with this. We'll move on with this. Right. I know what to do. Why set limits? What? Do I set limits here? Right. Okay. Set limits here. Yeah. Let's set limits. Let's see how this will help. All right, better, much better. Much better. All right. So what do I need? Okay. Yeah. So I think this is good now, right? And I don't know if I want to go ahead with this. I've not covered the bulk majority of what I want to cover today, right? Okay. So this basically is the plots of neutron density, and I was only trying to add colors. I was only trying to add shadings in between them, right? And I could do that, but considering my time and the fact that okay, which is red, which is blue. Okay, this is blue. Let me just do it like this. Okay. Right. Okay. All right. Okay. All right. So it seems I need to work on the spines. I just saw that now. I'm gonna work on these spines. Let me use this. Okay. All right. 1.08 as usual. It's a top one, right? It's a top one. Yeah, better. So this somehow should do, right? But for the shading, this is almost good to go. Right. So this basically is the last plot I'm having for the visualization aspect. Let me see if I could quickly do one or two things before really moving off. We have these density labels of color. Yeah, this is X, right? Right. Okay, let me do this. Let me use this. For both. Okay. Next. All right, I see my problem now. Okay. Let me use this. Good. All right, yellow and green. So, yeah. All right. Oh, this is less than, this is greater than or equal to, then this should be less than. Yeah, because if this should be less than. All right. Good. So this basically is what I've been trying to do. So this is this shaded portion is the crossing where we have the ball effect, right? So let's move on to something else. All right, let's move on to something else. So please, guys, while writing your own codes, just check up for all those little mistakes, right? For example, this was a major problem. I omitted it, and because I duplicated it, right? So that's basically how you do the cross plot, right? So I'll be moving to doing some of. I know my time is up. But let me just do just one more thing before I just. So when you normally when you bring in data, when you are given data, for, like I already started explaining, right? There are a number of things you want to. There are a number of ways you want to explore. You want to see the data, if it's even possible to do. Dr. Fatai talked about machine learning and the limitations. So you want to see if it's even possible to do machine learning with it, right? So I'm going to be needing some important plots, some important libraries, right? And I've imported most of them. I just, but I'm going to also be using Seaborn. So Seaborn. So I'm going to import it, and I'm going to be importing maths. I'm going to be importing this one we call missing no, right? And basically that's all I'll be needing. At the point I don't know if I'll get up to there where I will do 3D plots. I might be using this plots, this function from Matplotlib, right? So plots. Import axis. Right. So yeah, for 3D axis. So I think these are just the only libraries I don't have already here. So let's say we import a particular data. So let's just use this. Of course, we use pandas to read it. Yeah, I know this data set from the first machine learning competition. Right. Yes. Right. All right. So let us first of all, let's see. We might want to see the wells that are available, the unique wells, because if you check the data, you discover there are different well names. Let us see the unique wells that are available before we move on. We might want to see the number of unique wells. Sorry, this is supposed to be well. Oh shit. All right, so you run this function, and then you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think 11 well, no 12. It should be 12, right? You could if instead do this to get the number 12, right? And that's the first thing you do, right? I want to see the number of I just want to see the number of unique wells in this case, right? So I'll use this library. Sometimes well log data might be missing. Some points, there might be data points. There might be points where data is missing, right? And you want to visualize. Normally, you create something like a heat map. The heat map will show you where the points. Sorry, guys, this noise. Sorry. Sorry, you might want to create a heat map, but this time around, I'm going to be using this function, this library called missing no. It's I think it's much better than a heat map. That will actually show you the points, different points where in the data where there are missing data, right? So it's just as simple as this, and basically it uses matplotlib, and it will show you this. So you can see that in this particular column, we have complete set of, nothing is missing. But each of these, you could see that we have, if you count, we have 1, 2, how many columns have complete data? Just about 5. 1, 2, 3, 4, 5, okay, 6 or 7, right? So you could actually see that, and then you could see the name of the columns at the top. Moving forward, you can see this spark line here, right? This spark line shows the rows, right? Where there are lesser number of data in the rows, it goes left, and where there are more numbers, it goes right. For example, look at this point. You could see it here. It's coming towards this end, right? So that's it for that. And then you might want to go further. Without this, actually will enable you to know if you should proceed. Just for you to have an idea or understanding your data. You're just trying to seek data knowledge of the data, right? What exactly is happening? You are seeking insights, right? You are seeking, you are trying to understand your data first, right? Is it, what kind of data is this? And what are the limitations, right? So you might want to go forward to do this. This particular one will actually help to, one thing it will help to do is to show you the number of data in a bar chart format, right? The number of data points more specifically in each of those columns. So going ahead with this particular function, you see this there, right? So you could see the number of data points here that are available, and then the bar chart shows just reflects the number, the size, or the number of data points available, right? So there are lots to do. We have been working with we have just worked with the MSNO library. Using matplotlib, there are a number of things we could do to find missing data, right? So I don't know, I've overshot the time, and this is about where it starts getting interesting. right? So, right, all right, all right. Thank you, thank you. So let's move on with this. So I might want to uh okay. So I might want to do a kind of a count. I want to iterate through the number of I want to kind of create a kind of a copy of some of these. I don't need all these columns. I just need some of the columns. So I will just do this, creating a new variable data x, right? So I'll do this, yeah. And then inside this list, I'll put a list of the names I want. Right, and right, and this, that's for caliper. Bit size, I can see bit size here as well. And then what other thing I can see MPH? I will just look for the important the aspects that are more common, right? The forms that are more common, right? That we all know, right? So I will not pick so many of them. I know you know ROH will be already. So which other one? I think I can't find what other do I choose here? MPHI, can't find DT here. Okay, gamma is here. So I'll pick on gamma. I'll pick on gamma, and I think that will be all for now. Let me pick on, okay, I've seen this. Let me pick on this, pick up this. So that should be enough for now. All right. All right, so I'll just use this to copy. And then I'll use a for loop here. I believe you at least have an idea of the enumerate function, right? What it does, right? It's just to assign indexes to that particular list or iterables, right? We count through them, assigning various indexes that we are going to use or call in the for loop, right? So okay, yeah. So we have this, and we have. So these two are not they're not the data I want. I just need these ones, right? Like as in they are kind of they're not what I'm going to be using entirely, right? For what I want to do. So oh sorry. So from 2 upwards, from this point upwards, I'll need those are the list I want to assign. Those are the data I'm working with now, right? So in this for loop, this is what this for loop does. All right. So we have this. So basically, let's take up every number that is not null, right? From every column that is not any row that is not null, right? So we're going to use this to pick it up. I think I need to define this. It's columns we are working with, right? Okay, so that's the not null, right? Yeah. Then at the same time, you have to multiply that with the iterable plus 1, the counter plus 1. So it has to go higher. So in the next step, I will do this as well. So what did I do here? All right. So I'll do this as well. Oh, okay. Once my battery is low, let me quickly do that. Okay, I've charged it now. All right. So put it a terrible here and then in place. So this will actually fix it and not let it change in the next place it to be called. Then we have print, and column. So this will actually print it just to check. We use this print to check the number of just to verify what we are doing, if it's correct. So at the same time, we'll go forward to all right. Oh, this is depth MD. All right. Yeah. All right. So we might want to do this to group our data by well. And so having done that, the next one to do, I'll create a list of labels. So I'll create a list of labels, and we're going to use that. Okay. Let's do that here. Call this group data. Okay, I think it's fine. Just group all this. These are the points I want to use. So this will form the labels. So a list of the labels, and oh shit. Okay, that will be used. And then from here, I can do this to look through each well and column and plotting every kind of making plots for each of the wells and each of the data for each wells. So at the end of the day, you see a plot, a number of plots for each wells, right? So there are 12 wells. You see a number of plots for each of the 12 wells, and that particular plot will help you to visualize more specifically the wells that have missing data, right? So that's what I'm trying to do. So what I want to do now is to use matplotlib to let me just set up the plots or the subplot, right? So using this, then I'll do this, right? Subplots, and there are 12 wells, and I'll be going with 4x3, and any size will be just fine. Okay, I'm used to using 2020. All right. So here is where I create the for loop. So I'll use this both. So I'll use that group data from that group data, and then I'll do this, right? And all right. I don't know. I hope I'll be able to. Okay. So we have axis.set xlim, and we have 09. Okay, so I'm using 09 because I just want the number of this thing on the x-axis to be 9 for each of them. All right. Then for the y limit, I could do something similar. Y limit, right? But of course, we are talking about depth, so let's say I think it's 5,000 and this is 0. Okay. So now, the next thing I want to do is what I call the filling up, right? I just want to fill up. Now, the reason for the fill up is just for you to, it's the color that enables you to see, to visualize the point. So I want to give each of these, each of the curves, the reading caliper, BS, GRU, a different color. So I'm going to use this familiar friend, right? So I'm going to use him. I'm going to call this guy depth MD. Right. I'm also going to use, okay, of course, I'm going to call this guy too, because I'll use for each of them. And I'll give him a color, right? And call it gray. So I'll just do same for 1, 2, 3, 4, 5, 6. So we have 6 here. All right. All I just need to do is to change this here to the corresponding or the appropriate. And then Aruhichubi. And then GR. And then DTS. All right. All right. So, of course, we have to give them different colors. Just randomly, let me just give them different colors. We could say light green here, right? And then we even use light. I could use maybe violet. I could use with color. So for the next, I'm done with that. Next thing I want to do now is to kind of set up the grid and a label. I'll need a label. So I'll do this here to set up grid. So as this is equals to X, of course, right? Alpha. Environment. Color. Then color is black, right? So the grid is set up. What I just need to do next is the label. So, okay, supposed to say set file label. Okay, all right. All right. Let me just put that. That's the unit. Right, so we have this, and we have make this bold. I might come back to change it if it doesn't align with what I want. So with this, I think I can stop here to make the plot. All right. Do you think I should just make this last plot then? For it, is it, or okay. All right. Thank you. So let me use this tight layout and yeah, I might need to do some adjustments. So yeah, and 1, 2, 5. Just to make some adjustments. All right, so I've probably left something open. Where is that width? All right. It's fine, but we are not done yet. So this is more like each of the individual wells. I'll need to name the wells so that you see the name of the wells. So let me just do this quickly. Everything this is still going to be within the for loop, right? So we'll have this, and we'll have this, right? And ticks, right? I want to put first. Let me just start with putting everything that I think it's not there, right? So I'll just put first this. Yeah. Yeah. This is fine, right? Yeah, I could stop here, but there's usually something I could use here. No, this should be true. No, minus should be false, right? That should be false. Yeah. All right. So, okay. For the next one, I'll need to kind of make sure that each of these curves is, sorry, each of the names I'm going to be putting in is going to be at the center of the the ticks. So that's why I'm going to use this 0.5, 1.5, 2.5, 3.5, 4.5, and how many are there? Okay. 1, 2, 3, 4. Sorry, this is supposed to be 6. Right. All right. So 3.5, 5.5 should be 5.5. Yeah. So again, the minor has to be false. Has to be false. Let's make it true. Finally, one more thing. We'll set up the labels for the x-axis. The x-axis tick labels. Let's do that quickly. So we'll have ax.set s tick labels. So remember, we have made this a list before. We've declared a list, if that labels to be a variable for a list. Then we don't want we just want a vertical resolution, vertical rotation, right? Nothing more. And then minor in this case has to be true. All right. So No need for any other thing. Could even say the alignment of vertical alignment should be bottom. Yeah. So all these things are things you can just play with, right? Just to came across, I had to do them while I was writing these codes, if I can remember very well. So that's why I'm actually using them. So most of those arguments are optional. So you just do what you just adjust them. You have to be constantly adjusting and changing to until you get exactly what you want, or you get it as the exact way you want it, right? So that's just it. And then we're done. All right. So all right, so let's do this. Yeah, which equals to. So I could add a part here if I just to subtract the space between them. Right, so this is good. Where have I set a stick label? Set a stick label. This has no attributes. Set ticks. There's not set. Oh, this bullshit. This set ticks here. Set ticks. Okay, this is X. It's already defined here. That's no property vertical alignment. I probably didn't spell that well. All right. Okay. We have depths everywhere, correct? What we don't have now is we need to have the well names, right? I need to assign the well names on this. Let me assign the well names on this. Set it to name and font size 16. And maybe the font weight, give it a specific font weight. Be bold. So, and name has to be for each and every individual well. As in the for loop. Yeah, good. So you could see the well names on each one of them. All right. So the next thing I want to do is next thing I want to do is to just to ensure I in the right position. Right, I've calculated, just to ensure I've calculated everything properly, I've counted. So we have 4 by 3, and we're expecting this is 20 by 20. Yeah, and then the colors are good enough, right? PHI. All right. Have I set a depth range? Let me set it up. I think I need to, or do I just wait? Okay. Let me set a depth range. Okay. Somewhere here. So, Okay, I think I have. All right, I have here. All right. Okay. Ooh. All right, labels. All right. Okay, I think I'm missing something on the post on these figures here. I don't know. This is 1, 2, 3, 4, 5, 6, and so here we have 6. Okay, see no reason why 1, 2, 3, 4, 5, 6. Okay. So no reason why it's not plotting yet. Which minor? Okay. All right. This should be like this. One more time. Okay. Oh, I am missing something. I think I needed to fill in this position for each one of them. Yeah. Good. 3. All right. 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 So that should do it. Good. So in this particular point, you can see the data for all the wells, right? And you could see the points, the wells that have missing data, right? For each of these curves, right? You could see the wells that have missing data for each of these curves, right? So in fact, from here, you could just know the ones that will have will work for machine learning. So if, for example, I want to carry out the machine learning, what I want to do is to carry out a prediction of maybe one of the logs. Maybe I have other logs and I want to predict, let's say, the sonic log, right? So and I need to see the nature of the data I have for, maybe I'm supposed to do that from let's say the density and the neutron log, right? So I want to visualize my data now and see for that particular well if that is actually if it has the correct data. But this see the depth, see the data it has for only this depth, and for this only this depth, and for this. So it's just going to either for further analysis or for machine learning, it's just going to enable you to know which what exactly to do next, right? So let's move from here. Okay, we can stop here, right? We can stop here. It's I think we can stop here since we have overshot the time, right? Are you sure? Are you sure of that? Is that fine? Wow, there's a whole lot more, but uh, I'm trying to get to the point where by the time you are done, everything about EDA in petrophysics, right? With petrophysical data, you can be confident that you have the number of exciting things like we'll talk about knowing some certain things about the that data set contains formation names, contains lithology, and contains a lot of things. So you could do a lot of interesting things with that, right? And I don't know how long it's supposed to take me, right? But if you just give me a minute, like 5 minutes, I think I can just do one more thing, right? One more thing. All right. So let me just that could it will help you to know this particular thing I'm trying to do will help you to know the lithology. So which of the let's say you have bad hole, what we call a bad hole condition, right? So you want to know those lithology that were affected by bad hole conditions, right? So you do this kind of plot, right? So bad hole condition we call it bad hole conditions. Maybe swelling of the diameter of the well will actually reduce, or we have that there is kind of an expansion of the hole at that point. So the reading, the log data reading will be able to show how you can use that very fast. So I'll just do this. For this, I'll start with I'll first do for wow, okay, I'll just try my best. To do within this. All right, let me just with it. So when we talk about bad hole and the caliper log, right? So I'm going to be using the caliper and the bit size logs to in this particular in this stuff I'm doing, right? This actually is the difference between the difference between the bit size at that point. So that's what we are going to be using, right? That difference. So let's quickly do that, right? This we have this for the bit size is here. Yes, I think I included it before. Yeah, it's here. So so let's move on with that. Right. This time also by wealth. And then we have by well. Right. And then moving forward, now I'll create
Yeah, Tola,
right.
I can hear you.
That's what I'm. Then I will have to let you know what it is. It's better than just. Was I logged out or something? All right. Thank you. So let's go on. So I could do this in, oh shit. just have less than 5 minutes to do this, so it's not going to take a lot of time. So if I do this, so here I'll bring in the end rows, 3, six size. So normally 20, 20, right? So we have this data. Okay, sorry. We just create a for loop here for name and data. So axis in zip, right? So we use this grouped data. So we have grouped the data by well, remember? So with that, we have axis dot flat, right? And moving forward, we have axis dot set x lim. So we'll set an x limit for this. All right, so on 1, 20.5 on 1. Going forward, we also set a y limit for this. Okay, and 3 and 1. Right. I might need to plot first before even this. So let me do this data plot for this pandas function. Right. So with this, we can say x equals to nphi, y equals to arrow hob. So if cal. So that's where I bring in the that's why I bring in this, right? So for this, and for CMAP, I'm gonna be using okay, I've been using jets. You can use blues. Then we have these functions. I actually added them when I needed them. So remember, you can always check arguments for, if you kind of want to know the arguments that are available for a particular function, you just use your shift and tab here in your Jupyter notebook. And then by clicking here, you'll see the arguments that are available for that particular function and their explanations, right? For example, you could see the color map, explain, color bar. So for most times, you may not need all of them, or for most times, you don't need all of them. You just pick what you need. For that particular time or for that particular work, right? So finally, I will just set a title and I'll be ready to fire, right? So remember, we have used this name variable in a for loop to actually loop through the group data. So it's going to set the well name as the name of each of the wells. So for this, we have we can now plot this using the tight layout function, right? Tight layout. All right. So with this, I think we are good to go. We have not made any typo anywhere. Where is the typo here now? Kindly scatter. All right, see it here. I don't know. All right, I've seen it. No, there is no axis. I did not use axis, did I? This should be ASX, which is the first one. All right. This doesn't align with what I want to do. All right, so I guess I'll work on this in a second. So we have, if we have arcs in zip, and then we have arcs, right? So All right, I think I don't know if I hope I did this. Right. Oh shit. Didn't change anything. All right, so okay. If I set the Earth limit to be minus 0.15, I set the Y limit to be so all right, I think what exactly is my problem here? Why is my layout not looking the way I wanted it? Or is it coming from this end rows? I'll quickly, if it's coming from there, it just simply means I'll quickly remove it. Okay, end rows, we have this integer, yeah, which is good. 3, and this is fine. Okay, so this no reason why this shouldn't work. I absolutely see no reason why this shouldn't work. We have grouped data by well. I've grouped it by well. Okay, I'll start by defining the difference between these, right? And I've separated these two, right? And I've gone through here and the rules data. All right, so we have data.plots and a kind of scatter plots, and we have this. Oh, I just want to hope. I'm just wondering. Let me just pull out this. Okay, this is a for loop. Yeah. Let's see. Right. Wow. What exactly is my issue here? Okay. I don't know why exactly this is not working. There's no reason why this isn't working. All right. Okay, this should be right. Just one more minute and I can figure this out. On the same axis. Yeah, I'm actually using a for loop, right? And then generally this should give me shouldn't give me just 3 plots. I think there is a problem with my n rows. It should be a problem from here. Okay. Okay. I'm not getting you. Uh, all right. I think that's something is just wrong. Be one. Right. This cannot be one. Right. I'm using this math function, say, and if it's this length divided by 3, this cannot be wrong. This cannot. I hope I've not altered this data at any point, right? I don't think so. This definitely cannot be 1, right? Definitely cannot be 1. It's okay. Yeah. Yeah. Seems more like it. Seems more like it. All right. Seems more like it's 1, 2, 3, 4. All right. Where's the group data? Sorry, just a minute. So if I had set 12 here, sorry, there's no way to, it's actually a list. All right. Whatever. All right, so I don't know. I think I could just stop here. Probably I'm already exhausted. Let me put it that way. Yeah. Yeah. All right. I'll do just that. I'll do just that. Thank you so much. All right. All right. Why is this not showing? Since I've gotten to the end of the presentation, what else am I supposed to do? Huh? So someone says, how do I incorporate the pandas? Says PD is not defined. Huh? Okay, present. All right. How do I incorporate the pandas? Since PD not defined. Okay, I guess this question has been asked for a long time now. It's basically just you check your spellings. If you say the import pandas as PD, then and ensure it's uppercase and lowercase are it's abiding by uppercase and lowercase, right? If you are put it in lowercase, make sure you stick to lowercase, right? So that's one. Why does it keep, how do I move to the next? Why do I go to the next question? Is it just one question? I guess it's, how do I move to the next one? Well, this is not a question. Okay. I think all these are not, I have a question. If possible, explain at the end of the course how to draw a graphic percentage versus lithology. I don't know. Should I can't really start that session again, right? So I actually imagine I just, this was supposed to be in the whole thing. I'll try to work on my speed next time, hopefully, right? I'll try to work on my speed. I didn't get enough time to practice, like prepare for this because I'm a very busy person, but I'll try to work on my speed, right? I'll try to be faster so that I could cover more grounds, right? But yeah, I had this in mind, like it was in my workbook, right? So I couldn't cover that, right? I wanted to show the how you could how you could show the percentage of lithology versus depth, right? So, but I don't think I can take this now because it's time. I guess that's all. All right, thank you.
So it's any last thoughts, Dave? Any last thoughts?
No, I'm very delighted with the presentation. I just would like to know that the completed notebook will be submitted to you so you can post it at some point soon.
Yeah, sure. The completed notebook would be shared with everyone. So the structure is going to populate the whole notebook and share with everyone. So I just want to thank everybody for attending the fourth day. This is a long coding session. Be sure to take these tutorials to the next level. Be sure to modify the notebooks and continue learning, continue coding. Okay. Thanks everyone and see you tomorrow. Bye bye.
Bye.